Okay, so for this question, we've got these two blocks. M1 slides along, and it collides with M2, and then M1 stops, and M2 starts sliding across this surface with friction. And it asks us for the rate of change of the speed of the center of mass of the system after M2 enters the frictional surface. So rate of change of the speed, let's just talk about what that means. Well, that's really A. And it's asking about A center of mass. So in order to understand A of the center of mass, well, we have to look at the net force on the system, and we have to relate this to the mass of the system times its acceleration. Now notice this is actually the same as the impulse equation, right? So I could say the net force on the system, delta t, is equal to m system delta v. Right, these are the same because if I rearrange to find the change in velocity per time, I could just write this as m system times delta v over delta t, right? We saw this when we learned about the impulse equation, right? It's just F equals ma rewritten. But basically we're looking for this. So the net force on the system is actually just going to be the force on M2, right? Because M2 hits that frictional patch, and friction is an external force. And the frictional force on M2 is going to be mu, let me stick with blue color. It's going to be mu kinetic times the normal force of block 2, which is M2g. Right, and that's because it's only this block which experiences friction. But, right, even though the frictional force is just on this block, that means there's frictional force on the two-block system, right? The fact that there's force on this means there's force on the system. But we're not looking just for the acceleration of block 2. We're looking for the acceleration of the whole system. So we could do something like this to get the mass of the whole system. And then if we solve it, we get m2g over m1 plus m2. That's equal to change in velocity of the center of mass, right? This is really center of mass of the system over delta t, which is just A of the center of mass. So there we go. And notice that the acceleration of the system's center of mass is going to be less than the acceleration of just this block, right? Because the center of mass is some point in between those two blocks. And as this block slows down, well, the center of mass is going to stay in between them, but the center of mass point is going to slow down at a rate that is slower than the rate at which this slows down at. Cool.